All right, folks, today's lesson is going to take what we did last time and add just a little bit of a twist. Okay, so we still are going to be using our green note card to substitute with trig expressions. What's going to be different is we won't necessarily simplify to a single trig expression. Instead, we're going to be told what it's supposed to equal. What's different this time as well is we're going to have to make sure we don't skip any steps, because this asks us to verify that they are identities, which means we have to prove one step at a time that each side of an equation are equal to each other. Okay, so some things we did last time we talked about is looking for a common factor when we have two terms, getting a common denominator if we're adding or subtracting, factoring with maybe difference of squares other than looking for a GCF. We can distribute or FOIL when we see parentheses sometimes. We'll substitute with reciprocals, also with quotients. And this last one, conjugates, we haven't talked about a whole lot yet. We'll see one example today that uses that. So on our very first problem, again, what's different is it says it's equal to something, so we know what our answer has to look like, but what's different is we have to make sure that we're writing down all of our work in an organized fashion. So even though this says equal, we cannot treat this like an equation where we are okay to move stuff to the left and right using our properties of equality. Instead, we're going to only focus on one side, only focus on the other. We can never cross over. So what I want you to do is just go ahead and draw a line from your equal sign down and treat that as a barrier. We're never going to cross over that line. Because the left-hand side here looks more complicated than the right-hand side, we're actually going to start with that using some substitutions. Okay, so have your green note card handy. We're going to be using that all throughout today. Cosecant to start out with, that's one of our reciprocals, so that's 1 over sine. Cosine is a regular trig expression, so we'll leave it alone. I'm going to go ahead and put this over 1 since we have a fraction showing up over here. And tangent, sometimes we leave it alone and sometimes we substitute with the quotient. Because sine and cosine are happening over here, I'm going to go ahead and substitute this with sine over cosine and hope that nice things happen for us. All right. With multiplication, we can go straight across, or we can look up and down to see if stuff cancels. So because we have a cosine on the top and the bottom, we can go ahead and cancel those out. Again, this is only fair because it's multiplication. That does not work for addition or subtraction. Same thing with the signs, and we're left with 1 over 1, which is 1. That's good news because our other side was 1. Let's go ahead and drag it down so they're in the same line and put an equal sign in the middle for me. We just verified that the left-hand side was the same as the right-hand side. That's it for that one. Okay, we're going to do similar process on number 2, but not necessarily with what it's looking at originally. It doesn't look nice on either side. So we're going to work with probably both the left-hand side and the right-hand side for this one. Go ahead, once again, draw a straight line down so we know we can't cross over that equal sign. And what I want you to do, anytime you see squares being added or subtracted, and don't forget the number 1 is also a perfect square, you need to be under your Pythagorean identities. Okay? On your note card, you're looking for if there's a Pythagorean identity that has both secant squared and tangent squared, and there is one. Now, if we want to get secant squared and tangent squared on the same side, on your note card you had to move over the tangent squared, and when you did, you were left with the number 1, so we can make that substitution. Okay, that's as simple as it gets, so we need to move to the other side now. Now, what I want you to always focus on is what you're trying to get to. We have to multiply tangent times cotangent, and we're hoping for 1. So, again, we're using substitutions here. Because I know I'm having to get to the number 1, tangent and cotangent, remember, are the relationship with reciprocals. They are reciprocals of each other. So if you wanted to leave tangent in this case as tangent, we would just call cotangent 1 over tangent. And again, we want to have a fraction over here so we can see that those cancel. Another option, if you wanted to switch to sine and cosine, that would be an option here. Cotangent using your quotient is cosine over sine, and they still are going to cancel out to make you have a nice 1 when you're done. Okay, so it's okay to make that substitution as well. So again, bring this down so they're in the same row, put an equal sign, we are verified. They won't always be only a couple steps. We're going to look at a couple here that involve a little bit more work. So first on number 3, we have cosecant and secant being added together, and they're not squared. So that's really important. This is not a Pythagorean. Nothing's squared there. We can't use it. Same thing on the right-hand side. That 1 plus cotangent isn't getting squared, which means we can't substitute with the Pythagorean on that one. So what we're going to do is just substitute with our reciprocals and hope for the best here. So starting out, cosecant we can call 1 over sine. Secant we can call 1 over cosine. And we're going to do that same thing over here. Instead of cotangent, we're going to change it to sine and cosine. That way we're consistent on both sides. So here, cotangent, we've got cosine over sine. Okay? But what I don't want to do is have a fraction inside of another fraction. So we talked about this last time. You can always get rid of a denominator first or later, but it's nice to get rid of it early, by multiplying by the reciprocal. So what you can do here is multiply. Notice I put parentheses around it because it's really important, since we have 2 terms, that we emphasize that this denominator goes with both of them. We want to multiply by the reciprocal of the denominator. Our denominator was cosine, so this would be 1 over cosine. Okay. Now, there would be nothing wrong with you writing 1 plus that cosine sign, because again, I want to show you what's going to happen when you're on your own and you try something and maybe it doesn't work so great to begin with. There is nothing wrong with writing it this way to start out with. But again, anytime you have a fraction inside of another fraction, please use parentheses to tell me what part of the fraction you're in on each of them. Okay? From here, we're looking over here to kind of see what happens. We've got a fraction 1 over sine. We've got a fraction 1 over cosine. We have 2 pieces on this one, so it might be a good idea to distribute here and see if any nice things happen for us. I'm also going to talk about the next step for this one and really what's going on with this original as well if you took another method. So here, I want you to show that you're distributing if you are, so draw those in. This is a proof. We're going to show every step. So 1 times 1 over cosine is 1 over cosine, and that's really good news because we see that happen on the left. Okay, and for this one, when we multiply them, we've got cosine on the top, and we've got sine cosine on the bottom. Just smush them. Then, hopefully you notice, on top and bottom we see the same thing. Again, it's fair game when you do not see a plus or minus to cancel straight up and down. So we have 1 cosine, just bringing down in each step, anything you don't change. And here we simplified, there's a sine left, but it's left in the bottom, so we have to put 1 over sine. And then that looks really close to what we have over here. The only difference is the order. We'll go ahead and switch the order on one of the sides so they match exactly. Okay. But I want to show you a different way for this one because it's going to be very helpful for certain problems. And this actually showed up on your homework from last time. When you have 2 terms on the top but only 1 on the bottom, you can always divide them on the left side and divide them on the right side and simplify. What that would look like if you had written it like this is we want to take this 1 and divide it by the denominator. So that's 1 over cosine. And then take this second side and divide it by the denominator. Again, it could have looked like cotangent over cosine, but we'll want to make that substitution anyway. So it doesn't matter whether you did it first or second. But what we want to do is, again, make sure that we put parentheses around things so that we know where the major fraction is. Okay, from here, in this step, we've already taken care of the cosine on this side. So I'm just going to bring that down. But again, multiplying by the reciprocal, we want to show our work. So the cosine over sine stays. And we multiply by the reciprocal of cosine. That's 1 over cosine. So just a little bit different way to get to that same math that we did here. It's not different operations, it's just a different order. Okay, we substituted first, multiplied by the reciprocal first, versus splitting it up, dividing, and then using substitution and reciprocals. Same final answer. I really want to emphasize here on these, it's okay if you do these differently than the person next to you. It's okay that if you do them differently than me. You just have to show every single step so that somebody looking at it would be convinced that you did the math correctly. All right, again, I see some squareds happening on number 4, and anytime you see squareds being subtracted, you want to look if they are Pythagorean identities, because if they are, it makes our life really nice with substitution. Okay? In this case, if you look at your Pythagorean identities on your note card, there's no equation that has both tangent and sine in the same one. For that reason, we cannot substitute that way, but we can substitute individually to try to help us. So because we've got tangent sine on both sides, but there's really nothing we can do here, it might be a good idea to change our tangents into something with sine so we can actually subtract, so we can actually multiply these together. So with tangent being squared, we're going to call it sine squared over cosine squared. And then again, I see a fraction, so I'm going to put this one over 1. We'll do that same thing on the other side. We've got sine squared over cosine squared, but on this side, we're multiplying. Okay. What I want you to do right now is pause the video and see what you would do next with your operations to try to simplify this. Again, it doesn't matter what they look like at the end as long as the left-hand side and the right-hand side match. All right, you probably went over here first because we can multiply straight across. You could write sine squared times sine squared, just smushed. But sine squared times sine squared is sine to the 4th. So the simplified version of that would look like this. And on the bottom, we just have cosine squared. Okay, that way we have one fraction. So either sine squared times sine squared on top or sine to the 4th. It doesn't really matter as long as we can get the left-hand side to look like that as well. On the left, we have subtraction, so we need a common denominator. Okay, so there's 2 ways to get a common denominator, and I'm going to show you both because at some times we're going to need both. So the first way is the old-fashioned way. If you want to get a common denominator between cosine squared and 1, you first decide what the common denominator between the 2 would be. If you've got 1 and something, it's always the something. So we can make this look like cosine squared theta. But because it's a proof, we're going to show our steps. So this one's already over cosine. I'm leaving it alone. This one I have to multiply to make it look like it. So whatever we do on the bottom to get that common denominator, we also have to do on the top. So to multiply to get cosine squared, we have to multiply by cosine squared itself on top and bottom. This says we're multiplying by 1, which doesn't change the value of our expression. That's important. Then, now that we have a common denominator, we can just write straight across what we came with the top over our common denominator on the bottom. So on the top, we should have sine squared minus this product. They can't simplify, so you just smush them. And our common denominator is cosine squared. The second way to do this, and it will work anytime there's not a common factor between these things. So cosine squared and 1, there was nothing in common with. If you had like cosine squared and cosine over here, you would not want to use this shortcut method I'm about to show you. So this sign squared we can actually get by taking this times that straight down with an x. And this second term we can get by taking our second portion of the x going up. Cosine sine is the same as sine cosine, so order doesn't matter there. The sine coming from the middle term sine. And then our common denominator you can always find by multiplying straight across. So if you're using this method, you can skip from here to here, but again, it is only useful with examples like this where the denominators do not share a common factor to start out with. Okay. From now, we have to still somehow get our equations to look alike, and on top we have sine to the fourth, and on the bottom we have cosine squared. Remember, I keep telling you, you want to be looking to the other side always to see if what you're substituting with is actually helpful. And it looks like our denominator looks good already. So we just have to make sure that the tops are equal. We have to get sine to the fourth, and remember, that's just sine squared times sine squared. I've got sine squared showing up. We just have to make sure there's two of them. Well, I want you to remember that we find counting the terms helpful. So there is one term there, two total on top, and only one on the bottom. Okay, when there's two terms on top and one of them's messy, look for a GCF. Okay, a lot of times there is. In this case, sine squared shows up in both of them, which means we get to factor it out. When we factor out, we still have to have two terms left over. So sine squared out of sine squared, you have to remember, is 1. It doesn't magically disappear. Then minus, when you take a sine squared out of this part, you're left with cosine. And then we can bring our denominator back. Again, we said we needed sine to the fourth. Here's our sine squared. This would have to be sine squared as well. That's the only way that that works. I hope you recognize the 1 and the cosine squared are both perfect squares, and look at your Pythagorean again. This shows up and does actually substitute to be sine squared. Okay, you cannot skip to say that's sine to the fourth because you didn't do the substitution. Every single step has to be there. And then we can finish with sine to the fourth. If you had over on the right-hand side kept it as sine squared, you could have left it at that stage to say they're equal. Always bring down to show me that they're exactly the same on both sides in your final step. All right, the last one we're going to go over together is number 10 on the back side, and I chose that intentionally because this is where the conjugates happen that I was mentioning at the beginning. So if you'll notice, we've got tangent happening across from each other, and the other way we've got secant plus 1 and secant minus 1. Those are conjugates. When you see conjugates, in your problem, we're going to actually use them to help us simplify, because conjugates do nice things for us. When you take something like a plus b and multiply it by a minus b, that's what a conjugate is, same terms, but one's minus, one's plus, and FOIL them, you get a squared minus ab plus ab, I'll call this one a plus, and then minus b squared. Your middle terms go away, and you're left with what's called a difference of squares. Well, why that's helpful for us now is difference of squares often turn up on our Pythagorean identities. So we're going to use them to help us. Now, remember, we cannot cross this equal sign. So if you see a fraction equal to a fraction, sometimes our instinct in math is to cross multiply. That is not allowed here. Okay, we cannot cross over that equal sign. We can only work with one side at a time. Okay, so on this one, when you're dealing with this process I'm about to show you, you can choose either side. It does not matter, but we're going to work through without one side the whole way through. Here's how it works. I'm going to use the right-hand side. I want you to start by just copying down the original. And what we're going to do with this is actually multiply by the conjugate of whatever side you're working on. So since we're working on the right-hand side, we want to look at the conjugate of secant minus 1. So make a fraction, and we're going to multiply by secant plus 1, but we're going to do that on top and bottom. Remember, we're only allowed to do things that are multiplying by 1 because that doesn't change the value of the problem. Everywhere we see two terms, I want you to go ahead and put parentheses on it. And while you're doing that, keep an eye out on what's happening on the left-hand side, because remember, we have to get to this. Now, hopefully you notice the secant plus 1 did show up on top, so that's good news for us. But we have to make somehow this tangent go to the bottom and all this other stuff disappear. Okay, so here's what we need to do. With multiplication, nothing cancels across from each other because these aren't the same. So we're going to multiply straight across. And when you see parentheses, sometimes it's good to distribute or FOIL, and sometimes it's not because it doesn't help us. Because secant theta plus 1 was already on top as written, and that's what's happening on the left-hand side, we don't want to distribute that tangent through. It'll only make things messier. So just rewrite tangent theta smushed up next to that quantity, secant theta plus 1. On the bottom, though, we just got finished talking about how when you multiply conjugates together, nice things do happen. So we're going to FOIL these. Secant times secant is secant squared. Okay, then we've got plus secant minus secant. Conjugates will always multiply to a difference of squares, so I'm okay with you getting rid of those middle terms without writing them down. Negative 1 times 1 is negative 1. From here, again, we're taking a peek over here. We've got the secant on top, but we have to get rid of these this tangent and whatever's going on here. Now, to get rid of this tangent, we have to have a tangent happen on the bottom, so we're hoping some substitution can happen here. Do not substitute secant as 1 over cosine. That's going to cause an ugly fraction. Instead, remember, we've got a Pythagorean here. A difference of squares is showing up. So look at your note card for me. We're looking where secant and 1 happen. And that is equivalent to tangent squared. Okay, from there, easy finish. Tangents cancel out again because this is multiplication. We're okay to cancel up and down. So secant theta plus 1 is left on top, and one of the tangents cancel, but we're still left with 1 on the bottom. And that's equivalent to the beginning. We'll just drag it down, put it right next to it, to have a matchup. And we're done. All right. What your assignment is going to be for your homework is actually finishing the class examples. Okay, in class I had them work with a partner 5 through 9, 11 through 12. Okay, if you can find a partner to work with, I am fine with that when you come back, or you can work through these alone. But what you'll have to do is actually be able to explain each one of these from the class examples. I also circled a few problems on the homework assignment. You only have to do the problems from the homework assignment that I circled. The rest will be your homework for next class. But next class we are going to actually go through these proofs together. We're going to present them. And so each team will be assigned one of these proofs to present. So make sure if there's anything you get stuck on your class examples or those circled homework problems, you come see me so you feel good for next class.